As an industrial engineer, I organize factories for a living,
Okay.
but I realized I never organized the workplace where my own ideas are born. For me, this place is like a sanctuary where I design, learn, and transform abstract ideas into 3D printed reality. But honestly, my workspace has become inefficient, draining my time and energy as I constantly search for tools and parts. So I've decided to follow Honoris Fall's advice.
Organization is the foundation of efficiency. Disorder creates waste and useless toil, a place for everything and everything in its place.
The first step to efficiency is truly to analyze the space where I work. My analysis considers ergonomics, tool families, power requirements, usage frequency, and the optimal process sequence. My workspace is made by 4 zones: tooling zone, assembly zone, the design zone, and finally the 3D printer zone. So I started first by analyzing my movement inside the workspace, step by step and side by side. As a result of this analysis, I figured out a major issue. Securing tool support restricts access and creates clutter. Regarding the tools requiring power, like my soldering iron and tape gun, must be located close to a power supply to eliminate wire mess. Excess items like storage cups and projector mounts are taking up valuable space that I need to reclaim. Step 2. Simulation. I've added this phase to ensure considering all constraints and scenarios virtually before coming to reality. Before doing any action, I should first clear the workspace, and to do that effortless, I use Gemini and PowerPoint. And to remove the background, it's so simple. You double-click the image, you select delete the background, and you mark the zones to keep. And finally, the background is deleted. Then, I followed the same method to simulate the optimal positioning of the different components. Simulation confirms removing the wood support and centralizing tools on the shelves will maximize efficiency. As for the electrical tools, they should be grouped together and placed close to the power supply to minimize cable clutter and avoid messy wiring. Storage cups and the projector mount should be removed and placed without takes. Step 3. Action Plan. With the strategy defined, it's time to move into the realization phase, starting with emptying the office from all components. For the tooling zone, I decided to design a new big board to consolidate all hands tools into the wall. To get the correct big board dimensions, I first drew the shelf with its real dimensions in SketchUp, then designing the big board on top of it. It only took about 2 minutes. First I took a picture of the shelf with all its measurements. Then I asked Gemini to generate a custom VBA code that automatically drew the shelf in SketchUp. Finally, I used the same method to create the big board, taking the 3D printer's maximum print size into account. Next, I measured the dimensions of each tool to ensure they would fit properly on the big board. After that, I designed for each one of them a custom big board hook. Regarding the electrical tools, I decided to place them on the left side of the cabinet, close to the power supply. I then designed a custom support for each tool to keep them organized, easily accessible, and reduce cable clutter. For the third part, I spent some time finding the best position for the projector and the microphone. The optimal solution was to use an ergonomics style support. To reduce cost, I first experimented a metal bar that I already had to see if I could build the support myself. Then I used PowerPoint to simulate and visualize the concept before starting the detailed design in CATIA. Step 3. Realization and 3D printing. In this phase, I manufactured all the required components using a 3D printer to bring the design to life. The process started by converting each CAD model into an STL file, which is the standard format for 3D printing. I then imported the STL file into Curify, where I adjusted the printing settings, generated the toolpaths by slicing the models, and exported the G-code. Finally, I printed all the parts and prepared them for assembly and installation. The printed workspace and mounts, layer by layer, building the custom brackets and mounts I've engineered. I inspect the printed parts, removing the supports, and verifying the fitment for the assembly.